In this notebook, we'll explore what Ray Dalio referred to as the holy grail of investing, how by increasing diversification you are able to reduce your overall risk as measured by the standard deviation of portfolio returns. The idea here is to show that if you can create a basket of uncorrelated or low correlation return streams, you can reduce your portfolio risk significantly by increasing the number of streams in your portfolio. The first step is to increase the resolution of your plotter to retina level and import the required libraries. In order to get the same results as will be shown, set the random seed to 42. Next, you create a function that simulates n return streams with a given mean and standard deviation, which you name risk, and a given average correlation, which you name core or CORR between them. Ideally, you will have real data and be able to generate real return streams for the assets in your portfolio. We are using simulated return streams here to generalize this example. Just to make sure, let's do a sanity check by calculating the means and standard deviations of the return streams. This is the simplest way to construct such a portfolio. You create an array of pairwise correlations between assets that are equal to a given level of core. The important point is that the average of all pairwise correlations should be equal to core, or 0.6 in this example. Then you'll create a helper function to calculate the pooled risk given a number of return streams in the portfolio. Next, you'll build your simulated data set. You'll analyze your return streams with risk levels in the range of 1% to 14% for varying number of streams ranging from 1 to 20. You'll plot the risk levels for different average correlations ranging from 0 to 0.7. You can already see in this array where the first line represents the risk for a one-asset portfolio for correlations ranging from 0 to 0.7, how the portfolio risk decreases as you add more assets. You can also see how the decline in the risk is much sharper when there is a low correlation between the assets. For example, going from one asset to 10 assets with a correlation of 0 reduces your risk from 14.14% to 4.44%. With a correlation of 0.7, the reduction in risk is only from 14.12% to 12.1%. Next, you create a function that produces a plot given your simulated data and a chosen risk level of 10%. Your plot shows how diversification benefits a portfolio with assets that have a risk level of 10%. More highly correlated portfolios do not benefit as much from increased diversification. You get only small reduction by adding highly correlated assets beyond a total of 3 or 4. In contrast, you can halve the risk by adding just 6 or 7 uncorrelated or more realistically weakly correlated assets to a portfolio. The benefits of diversification are reduced risk through exposure to different sources of trading revenue. The insight that Dalio brings is that the construction of a diversified portfolio through a combination of uncorrelated return streams significantly reduces your overall risk, raising in turn your return to risk or Sharpe ratio. By the careful mixing of uncorrelated assets, you can capture this true low-risk alpha. This gives you the ability to add leverage and greatly increase your potential returns. This is the strategy that Dalio and Bridgewater have used successfully in their risk parity approach, which is described in the links shown.